Real quick little background here on the Coalition for Deep Space Exploration. If you're not familiar with us, we're an industry trade group of about 50 or so companies that advocate for the importance of space exploration to our country's strategic national interest, science, STEM advancement, et cetera. We advocate around the country, but we're based here in Washington, D.C. And we are really excited today to have two astronauts, former astronauts who have been to space, Doug Hurley and Charlie Precourt, for this Space 101 series. Space 101 series, I think this is the third or the fourth that we've done. We have another one coming up, we think May 6th, but stay tuned for that date. We're still working logistics on that, and so we hope to be in touch with y'all soon first, and you should, if you're getting these emails, then you should get an invite for that future one. So just a little bit of background today about our speakers. I know that these two names don't really need an introduction, so I'll be brief. Charlie Precourt began his career with the U.S. Air Force as an instructor pilot and later as test pilot. He's flown more than 12,000 hours in over 90 types of civil and military aircraft and was selected as a NASA astronaut in 1990. Charlie flew on 4 space shuttle missions, including both the first and final space shuttle missions that docked with the Russian space station Mir. He also served as chief of the astronaut corps and deputy manager for the International Space Station. Doug Hurley began his career with the U.S. Marine Corps, where he made 3 overseas deployments to the Western Pacific. He later served as an F-18 test pilot and became the first Marine pilot to fly the F-18 Super Hornet. Doug has logged over 5,500 hours in more than 25 aircraft. He was selected as a NASA astronaut in 2000 and flew 2 space shuttle missions, including the final mission, STS-135. He also commanded the first crewed test flight of the SpaceX Crew Dragon to the International Space Station. Y'all may remember that just coming up on almost 2 years ago. Really exciting mission. So you can see these two humans are experts in the topic of why explore space with humans. And we're really excited to have them today. Now I'm going to turn it over to Kay Anderson with Northrop Grumman, who's going to be our moderator today.
Thanks, Kristen. We'll begin then with Charlie and Doug each taking a few minutes to provide their perspectives on why humans are so important to be a key part of space exploration. And Kendra, if you'll go ahead and go to that blue dot slide, thank you. And Charlie, do you want to go ahead and kick us off?
I would, thank you, and thanks everyone for joining us. It's a pleasure to, especially now, being in the final dress rehearsals for Artemis 1 and our initial phase of the program to return to the moon. It's pretty exciting to be talking about, stepping back and why are we doing this. As we talked about this particular topic, I couldn't help but remember some of the things that Carl Sagan had said back as we were getting ready for our first docking with the Russian Mir space station. This is a picture of what he called the pale blue dot. You can see the sunlight ray vertically through the middle of the image there, and a tiny white dot. He called it the pale blue dot. Carl was an astronomer and an astrophysicist. He was also very prolific in his writings and his presentations about space. And he made a point of asking NASA to turn the camera of the Voyager 1 spacecraft as it was leaving our solar system in February of 1990 to turn it around and try to get a picture of Earth. And so the pale blue dot here is in fact where we live. And it's taken from a distance of 3.7 billion miles from Earth. And what he said was pretty profound when you think about it, where we are in our universe and what we know and what we don't know yet about our universe. And I'll just quote from him a little bit here. He said, "Everyone you know, every human being, whoever was, lived out their lives on this planet. Thousands of confident religions, ideologies, economic doctrine, every king and peasant, every mother, father, hopeful child, every inventor, every explorer, every teacher in the history of our species live there on a mote of dust suspended in a sunbeam." And so, it makes you wonder about our quest for knowledge and what we know today and what we might know in the future. And it's through exploration of space and the quest and the inspiration of humans reaching further beyond that one day we might actually know that there is life elsewhere. For today, this is the only world known that harbors life so far. And the pale blue dot is uh, the only home we've ever known. So I always looked at human exploration of space as something that's reaching out in a quest for knowledge. It provides an inspiration for advancing our species and ensuring the future of our species. So when you think about what Apollo and Shuttle did, in particular, when you look at that lower left corner of this image, that's the first view of Earth taken by humans when Apollo 8 went around the backside of the moon on Christmas Eve in 1968. And Frank Borman, of course, with that crew, was the first to see this image, and they recited from Genesis. And even though we didn't have internet and cell phone in that day, nearly half the planet heard their transmissions from the other side of the moon. And so these kinds of inspirations led an entire generation of humans to join an aerospace profession, a workforce that has advanced our way of life, our lifestyle, our standard of living. And for us here in the United States in particular, as leaders in human spaceflight, it is a way to benefit our economy, to further our national security interests. Being leaders in the world allow us to lead the way in what we view as the best way to be a civilized world on this blue dot. So I think of four things when I think of the why that we send humans to space. Inspiration being among the first that comes to mind, but the benefit to our economy and our national security leadership, and then the spin-offs to business and society. And last but not least, I'd also say that it's been tremendous in bringing us closer together around the planet with international cooperation. And I would just invite you, if you're interested in looking back in history a little bit, and again, you kind of have to know where you've been before you can determine where you're going. And looking at what Carl brought in the form of historical context here, just Google Carl Sagan and the pale blue dot and have a listen to what he had to say. I thought it was very inspirational and particularly poignant given the current events in the world today. So I'll leave it there, Kay, for a moment, because I know Doug's going to talk quite a bit about inspiration and what it brings to us to be exploring in space as well.
Yeah, thanks, Charlie, and we'll turn it over to Doug.
Thanks, Kay and Charlie. And for those of you who don't know, Charlie is the guy who's hired me twice, and he doesn't realize how much I owe him. Just been such an exciting inspiration to me, and it's just led to just a lot of incredible experiences that I've had as my time as an astronaut and now here at Northrop Grumman. Really it is about inspiration for me. I don't think I realized it at the time a couple of years ago when we launched into space on the DM2 mission up to the International Space Station. We kind of found out maybe secondhand or while we were on space station, how many people were tuned into that mission. The first mission in 9 years from the United States, from Florida, and like I said, I didn't realize how much people were interested and inspired by the effort that NASA and of course SpaceX did to get us back into the human spaceflight game from the United States. It's just really neat. And I remember myself growing up in the 70s, is where I have probably my first conscious memories, but just immediately being pulled in by Skylab and those missions, and then of course the space shuttle. And it led me down the career path where I'm at now, where I was a fighter pilot, a test pilot, and then lucky enough to be an astronaut. So the inspiration for this next generation of STEM is just, it's going to be huge based on all the things that have been happening over the last few years with commercial space and low Earth orbit, but then Artemis going to the moon, and then ultimately Mars. And so we're going to need so many people to work in those fields that support that, as well as the people who work in mission control, and of course the astronauts and scientists to go on these missions. And so it really is exciting to be a part of the space business these days. I think the other thing I would say is you get a lot of questions about human spaceflight, specifically, being expensive, being dangerous, and we've lived through all those aspects quite closely. Charlie joined the astronaut office not long after Challenger, and I was in the astronaut office, actually down on the runway at Kennedy Space Center, waiting for Columbia to come home in February of 2003. And so it certainly is dangerous, but the benefit to the greater good, to the human species, and to scientific exploration, we feel is worth it. And then some of the benefits that we've gained over the years from space flight, the NASA spin-off publication, I've looked at that before, and it's amazing to see how much of the technology that is part of the space program that's turned into commercial products. You can Google it. It's definitely a lot of information out there, but things like GPS. I don't think people realize the software for GPS. That was all part of the space program. Of course, the GPS satellites. It's just incredible how we use it without thinking almost every day now in our life. The weather satellites that we have predicting weather accurately. I know living on the Gulf Coast, that's which I did for many, many years. I'm frankly a little bit happy to be moving away from the Gulf Coast just because of all the hurricanes and the weather phenomena that you have there. But the ability to predict those things so closely really helps save people's lives and getting them out of harm's way as part of the space program. And then changing the environment on Earth, and then of course the communication satellites that we have. So it's just so many things have evolved from the space program. And I remember wasn't that many years ago, we were talking about NASA's budget as compared to the federal budget, and it's kind of stayed flatline for probably the last 30 years at around 0.5% of the federal budget. And I remember doing a little research. It was one of the first times I had to go out and give a talk somewhere, and I wanted to really understand the numbers. And I looked at it. In that particular year, the Navy had a larger budget for aircraft purchases than NASA's budget that given year. And to see what we've done with that budget and what we're about to do with Artemis is a real testament to the folks in industry as well as at NASA to make the best use of those taxpayer dollars for the benefit. So I think, Kay, I can turn it back over to you.
Okay, thanks for sharing your thoughts, you guys. And just to turn perspectives here, you hear that, especially when something goes wrong, we hear that space is hard. Something goes wrong, I say, oh, space is hard. And I have a colleague that when that comes up, she would say, no, learning to tie your shoes is hard. Learning to ride a bike is hard. Going to space is audacious, and it will always be audacious. Would like to hear your perspectives about that. Doug, do you want to go first on this?
Yeah, sure. I like that term, audacious. I think we say space is hard all the time, but in the end, it's a challenge because we're asking a lot of our equipment in any given human-rated system. There's probably millions of parts, thousands of hands have touched those vehicles, and we're all capable of making mistakes when we have a bad day. And so we're asking the vehicle to do a lot. We're going from 0 to 17,500 miles an hour to get to orbit. And then, of course, soon with Artemis, we're going outside of low Earth orbit, going to the moon, 250,000 miles away. So it really is, and I've done this maybe once or twice, where you stop and think about it, and you're just like, how can this possibly work? I'm riding a controlled bomb into space. But we have we just have some incredibly talented people at NASA and in industry that are beyond dedicated to make it happen. And, you know, as I said before, it's just incredibly inspiring to see this. And, you know, you think about it, as Charlie was talking about with that first picture from Apollo 8. I can't tell you how excited and anxious I am to see the high definition video from Artemis 1, hopefully, and certainly the pictures from Artemis 2 when we'll have a crewed flight around the moon, and to see those pictures, not only of looking back at Earth, but to see the moon up close and to get the perspective. That's as audacious as anything. Charlie?
I like that. Thank you. And yeah, Charlie, what are your thoughts on this?
Well, you know, I'll just piggyback on Doug there a little bit. I think the tremendous part of where we are today now finally is that we've built on learning how audacious it was to go to space, and it will continue to be, but we are on the precipice of being able to sustain deep space access. And I think we're talking about building out a gateway. We're talking about eventually getting to a platform on the surface of the moon that could be an outpost, much like McMurdo Station in Antarctica. And instead of, as hard as it was back in Apollo to put forth a dozen missions, we are now going to be able to go and stay. And that's because of being able to overcome the challenges that were earlier confronted with. You're taking humans to space. The requirements to sustain life in space are just tremendous. And so it's the learning of how to accomplish those objectives that eventually brings a stronger industrial base, greater technologies, more efficiency, more cost effectiveness, more business growth, and better way of life for all of us on Earth. And so we're spending the money on the Earth to create space capabilities in a way that we haven't ever done before, because it is becoming more accessible and more financially viable. In particular, the partnerships between private sector and the government are ever accelerating now. And we should not imagine a world without space access. Doug mentioned GPS, our entire banking system, access to internet, all those things are becoming ever more dependent on the ability to operate in space. And we're just benefiting from that.
Okay, thank you, Charlie. Thanks, Doug. So we're going to space. Space exploration is important to life on Earth, but why humans? Why do we need humans to be part of that space exploration? Charlie?
Well, I kind of alluded to that here a minute ago, but it's the inspiration of knowing that we can overcome things that seem impossible, and what that does in terms of our productivity, our ingenuity, our engineering, our technologies, and those things that come back to us on the Earth because we were audacious enough to go try, really makes it for a productive endeavor. And so we have a partnership, I like to call it, between robotic and human space exploration. But if we don't send humans, we don't get the depth of that inspiration, the benefit of leadership, the overall outcome of productivity that we would get with robotics alone. So we send robotics where it is yet too difficult and or too costly and risky for humans. And then from that, we learn how humans can go, which dramatically and more rapidly expands the productivity that results from it. So, and lurking behind all that, of course, is that wonder that we have about, what will we learn that we didn't think we were going to learn by going. And most of the robotic exploration scientists I've spoken with acknowledge the benefit of this partnership between human and robotic space exploration and the value that the human brings. I'll give you one quick anecdote. I worked with Professor Sam Ting, who's a Nobel laureate in astrophysics and the study of black matter in space. And Sam had been not so much a proponent of human spaceflight until he put one of his experiments on my space shuttle mission, STS-91. And that experiment was a very long-lived investment in the study of black matter and high-energy particle physics in space. understanding our universe better. And as a Nobel laureate, that was his life, and trying to understand black matter. And so they took a leap from that community to put an experiment on shuttle. And had it not been for our crew on board, the experiment would have failed, because they had not completely enveloped the failure modes with the ability to manage it robotically. So from the flight deck, we managed to gather more information. I'm sure they're still distilling a lot of that data today. But Sam Ting became a very, very strong proponent of the partnership between robotic and human, just on that one experience alone.
Okay, thanks, Charlie. Doug, what are your thoughts here?
Yeah, it's funny, Charlie, you mentioned Sam Ting. We got to meet him down in the SSPF as we were down there for the MPLM on STS-135, and Dr. Ting was down there for AMS, STS-134. And Chris Ferguson and I were standing there, standard pilot program. He comes over to us, and of course, Sandy was with us, Sandy Magnus. And he proceeded to ask each one of us, where we went to school and what our major was. And of course, after Chris and I explained that we were, maybe not from the most prestigious universities ever, and he kind of nodded and said, and we were engineering majors, and he kind of nodded and said, yeah, you guys are from football schools. And then he looked at Sandy and asked her what she did. And of course, Sandy was a physics major, and he's like, oh yeah, physicist. And so he never looked at us again, and he and Sandy had a long conversation. So I knew right where I stood as far as Dr. King was concerned. Just get my payload to orbit now, and then we'll let the real smart people take care of it after that. But, Charlie mentioned it with robotics. It is such a companion, and I think it's going to be that way going forward. As you said, for the initial missions, until we figure out how to keep humans alive and safe when they go explore these different bodies or wherever it is, we send the robotic missions, and then we send humans when we have the systems all designed and well thought out. But it's also going to be a case of companion while we're there. I'm certain we'll have robotics, companion robotics while we're on the surface of the moon, and of course on Mars. And once again, they yield incredible scientific results, but the terrain, slopes, all those things, bog them down, whereas humans can kind of go around. I remember a story about Apollo 17 where they were able to just go around these boulders and really take advantage of their time. And of course, surface activity is always expensive, and you want to take advantage of every minute. And so, we can certainly save time with human interaction in those cases. And then, the one other thing, I don't know if folks remember Steve Squires. He was chief scientist, and I remember him making a comment about the rovers, while they were amazing to see and the pictures that they sent back, it was just a case of, he said it took 4 years to do a week's worth of field work. And that may be the case. I know astronauts, not all of us are geologists, and so it's well known that the Apollo astronauts were trained by some world-renowned geologist, and then we flew a geologist on Apollo 17, and by all accounts, he brought back the most significant piece of moon rock that we've had to date. And so it's always great to have the humans be part of it, and also a companion for the robotics. Okay.
Okay, that's great. Thanks, Doug. So we've talked a lot about why humans should go to space and be part of space exploration. Let's talk a minute about the how. And Kendra, if you'll give us, thank you, the Gateway slide. So Charlie, this slide shows the various elements of Gateway, but would you explain a little further why Gateway is critical to human exploration of space?
Well, fundamentally, the physics of going to the surface of the moon involves leaving Earth's gravity and then joining the lunar gravity field, and having the fuel to be able to manage maneuvering in those gravitational fields is a key ingredient of being able to fly in space. And to go to the surface of the moon efficiently, a gateway such as what is contemplated here in this expanded view allows a place to shuttle to and from the surface and to and from Earth without expending a lot of excess fuel. So the fuel is directly related to the mass that you take to the surface and back, right? So in order to minimize that and to be more efficient, you leave a lot of the mass in an orbit around the moon. That's what the gateway's fundamental purpose is to put it in an orbit that is essentially very, very stable, requires very little energy to maintain, is easy to get to from both the Earth and the surface of the moon, and provides an outpost of stable resources for crew, cargo, resupply, repair, energy, communications, a lot of things, right? That will make the operation on the surface much more efficient, much more redundant in terms of safety capabilities. So properly, you've got different elements of this gateway system that will be joined by international partners as we do at the space station, commercial companies and NASA to build out over time. And that will provide this outpost from which we can operate to the surface. And then once we're able to establish some infrastructure on the surface, it goes down and most of it stays, much like McMurdo Station in Antarctica. I like to use that as an analogy for people to understand the how. And I can't help but think back when I was a kid watching the Apollo program. I used to be excited occasionally. Once a month, there'd be a front page newspaper, pictorial about how we were going to the moon. And it was fascinating. This is how we go to the moon and stay, with an infrastructure that supports an efficient operation. So I'm thinking we're going to do a lot more on the gateway in another rendition of your program here, right, Kay? And
Right, yes. So thanks for giving us that overview. That was really helpful. And we are going to have another Space 101 that is focused on Gateway. So any questions on that, I'd ask folks to hold up for that. We'll have a lot more information here in about a month. We'll have the experts on for Gateway then. So one last question for me, and then we'll open it up to those online. So if you do have questions, go ahead and put those in the chat. This question directed to Doug first, and then Charlie can add on if he wants to. But the first launch of SLS and Orion, Artemis 1, is going to launch very soon and will be uncrewed, as opposed to Space Shuttle, where that first mission was crewed. So Doug, tell us what your thoughts are about that.
It's still to this day, it is amazing that accomplishment on STS-1. I've had, and maybe Charlie has too, I've talked to Crip and John about that more than once, and just to hear the story about that and why they decided to go that way. But just incredibly brave folks to take that on. We all come from, well, at least most of the pilots that are astronauts come from a test pilot background. And then, we always like to talk about the build-up approach. And a lot of times, certainly with space vehicles, you want to do an uncrewed test flight first, much like we did with commercial crew and are still doing with commercial crew, frankly. Just to make sure everything goes the way it's supposed to go with almost all the equipment and as similar a vehicle as you can do. And it just gives you that real-time data and real-time confidence that when you put humans on the vehicle, you should have a pretty good outcome. And so I think, as we work our way towards Artemis, that was the thought process during the development. And then much like we did with DM1 with NASA SpaceX, it was an uncrewed flight end to end. And Artemis 1 is going to do almost exactly the same flight profile. And one other thing of note is likely going to be a longer flight than the crewed test flight's going to be. I think we're on the order of 28 to 42 days, give or take, for the Artemis 1 flight. And that should give folks back on the ground some really good data on performance of all the different systems, not only with the launch vehicle, certainly, but then, of course, with Orion and its service module. So, I think a really well thought out architecture before we put humans on the vehicle. And really looking forward to Artemis 1, hopefully this summer.
Thanks,
Yeah,
Doug.
Kay, I'll piggyback on that a little bit, Kay, I guess, since you alluded to, maybe I could follow up on Doug's comment, but you know, the reference to STS-1 and both Artemis 1 and whether we fly them crewed or not, those are large risk trades that the agency and industry makes together as to what's the benefit versus the risk. And you know, with the space shuttle, we needed to bring the winged vehicle back, and it had to get on the surface. And the risk trade was we were more likely to be successful with that with crew than without. And so the argument swayed more towards bringing the shuttle on in the first flight with crew on board. I had been a proponent in some of the discussions early on to have crew on the first Artemis mission, because you could argue that the elements of the vehicle, the boosters, the main engines, even the core tank to some extent, even though it's largely modified now that engines have been moved underneath of it, and the Orion on top having already had an uncrewed mission, you could make an argument that it could go crewed the first time, and perhaps that would accelerate the program and lower overall costs. However, as Doug just alluded to, another part of that trade is how long of a checkout can you accomplish without crew as compared to with crew, and what is the risk to the crew? I'll never forget when I was flying flight test at Edwards, the general in charge of the base one time looked at a safety review of our flight test plan, and he said, well, why are we taking those test points into the air on this airplane when they can be proven and tested, and the answer can be given to us in a hangar with a vibration table on the components? And he was right. If you can test something without exposing the humans to risk and get the answer, then that's your answer. Try not to expose the humans to more risk than necessary. So the balance in the long run with Artemis 1 was to fly without crew. And certainly those arguments are had pro and con both ways on both vehicles, and they come out. We are, in fact, going to see now a sustained resurgence and a sustained presence in deep space. And so getting it right on Artemis 1 and fully understanding, like Doug said, the 28+ day checkout will allow us to be that much more aggressive when we do fly humans. So I think we're in a good plan, and it's pretty exciting to see this all coming together.
Yeah, that's great, Charlie. And I do remember you saying you'd go ahead and fly on the first flight, and so did Brian Duffy, and so did Kent Rominger, and every astronaut I've talked to about it. So I know you're all about that, but it does make sense why we're doing the way we're doing. So we do have some questions online, and we've got one from Alex Weitz with Nature. Can you talk a little more about how you envision the experience of the Artemis 2 astronauts? What will it be like for humans to be laying eyes on the moon close up for the first time in half a century? And how will that resonate with the public today compared to how the first Apollo flights did? Doug, do you want to go ahead and take that one?
Sure. Yeah, I just think, and we've kind of seen that a little bit from space station, frankly, just the quality and the technology of our equipment, to capture those pictures, and how much closer they are to, relaying what your eyes see. I mean, it's, I hate to use the term, but it'll be viral, those first pictures. And then, of course, the challenges as an astronaut, if you're the one talking on the radio, is to try to convey that in a way that resonates. It's, we're engineers, we're pilots, and sometimes we don't always have the best way to say things and convey things, but it's trying to relay that human experience of seeing the moon for the first time. And, the first human to see it with their own eyes in 50+ years is, I mean, it's going to be huge. I think it will reach almost anybody that has a phone and internet is going to see these pictures, and they're going to be relayed, and probably the video as well. So I and if you're the person actually seeing it, it's just, I can't tell you, it's just, it's an overused term, but it's flying in space is beyond surreal. And to have that be part of it, the equation where you're 250,000 miles away looking back at the Earth, incredible, indescribable.
Okay, thanks, Charlie. Anything to add on that?
Hey, Doug said it well. I referenced Apollo 8 and the fact that without the internet, half the planet heard their voices when they recited from Genesis. Now it'll be the full planet, and it'll be with technologies that allow our crews to take the planet and everybody on it with them and get just much better connectivity to what's actually happening and what they're seeing. So it's going to be really exciting.
Okay, thank you. And then Charlie, if you want to take the first stab at this next one. With the wet dress of Artemis 1, what are some things astronauts are keeping their eyes on during the critical test of this new vehicle? What are astronauts watching?
So it's a process. The entire buildup of the vehicle, getting it out to the pad, its interfaces with the tower, and all of the communication and supply lines that feed it. The crew's watching the performance of all of those steps along the way to understand the level of reliability, redundancy, and frankly, readiness for flight. And so they're plugged into every piece part of the scheduled flow. They're going to make sure that they understand where the tricky parts are and how we work through them, and they'll get real comfortable before they fly with the fact that this thing is going to operate the way we expected it to. Much like, to give you an analogy, a sports team goes through practice drills and they have to run an end around or a long pass or up the middle. When I was at the Air Force Academy, we used to tease our football team because we weren't that good then. Was our only plays were up the middle, pass, punt. Well, this is a team, and they're putting together a vehicle that's got to be able to do a little better than that. And there's nothing like having rehearsals of all the components ready so that when you put crew on for the first time, they're going to feel.
Okay, great. So, Doug, do you have anything to add on that as far as what astronauts are watching while we would do wet dress rehearsal?
Yeah, having lived it for about 5.5 years, you're just watching the teams come together. You're watching the teams hit their stride. It's a perfect analogy is what Charlie used. And, that was kind of our litmus test. And understand the astronauts are only a very small part of this whole system or this whole architecture and this whole mission. But yet you're along for the entire process. We were embedded with the folks at SpaceX for years, and every test, every change, every development, whatever the case may be, you're watching the teams work together, work out the kinks. Remember, this is the first time, the folks at Kennedy have launched a spaceship since STS-135 with people on it. And so, they've got and a lot of those folks are not the same folks that were there in 2011. So, it's just a case of practicing. And, it's kind of like as we got to the end of the shuttle training flow, and it was the same for DM2, you know when the team's ready, when the crew's ready, when you're ready, and when the mission control team's ready, the launch control teams are ready, and then it's time to go fly. And this is part of that. This is part of that build up to get ready to go fly. And the teams are learning a lot. They're learning a lot about themselves, their procedures, the vehicle, what the vehicle is telling them, and it's part of it. And we'll get there pretty soon.
Perfect. Thank you both. We have from Chitra Sethi, Tech Briefs. Every day seems to witness the emergence of new entrants in the commercial space arena, including new applications. Where do you anticipate the next generation innovations will come from that will drive the future of space exploration? Doug, do you want to hit that one first?
Yeah, it's exciting. I can't believe where we are in just a few short years. You think about just 2 years ago, we flew the first commercial spaceship to the ISS, and now we've had multiple suborbital flights and multiple orbital flights, private companies going. It's just amazing. And so, the low Earth orbit economy is literally quadrupling in size in a matter of months or years. We've got entrants to build commercial space stations, and it's just, it's almost mind-boggling how quickly it's happening and taking off. And, you know, I think as I kind of talked about before, NASA, you know, generates a lot of this stuff to the commercial sector when we do these audacious things. And then you've got entrepreneurs and private companies that are coming up with some great ideas. And I think it's this public-private partnership that's going to continue. And certainly that's what we're going to do, trying to get to Mars, just because it's such a big undertaking to go to Mars. You're going to need all those different aspects of commercial and private businesses, as well as nations and national space agencies and countries to get to Mars with people.
Did you want me to piggyback on that too? Okay, I think I would just allude to the business proposition for all of these participants. It wasn't but 10, 15 years ago that the real business case for space was really communication satellites. Those were the hardware products that were developed by industry that actually turned revenue in a big way. So if you could build a TV satellite or a weather satellite, you could put it up there and you could generate revenue by charging access to that information. Now there's an expanding variety of business cases that are starting to take hold. And that's really the challenge for us in space, is to find how we can exploit it profitably for this partnership Doug talks about between industry and government to make the most of it. And so if you've been on a trip somewhere and you watch somebody with their phone not being able to get internet access, how quickly they become frustrated these days. Now you see why there's satellite constellations going up that will deliver internet at high rates and access no matter where we are, whether we're on our boat off the lake, or if we're, you know, on the other part, you know, on a trip to Greenland or Iceland or wherever on a vacation. It soon will become ubiquitous and capable of tapping into wherever we are on the planet. And so people are ingenious enough to find a business opportunity in the access to space, whether it's, you know, pure scientific technology development, whether it's scientific understanding, whether it's improvements to our understanding of medicine and the human biology to improve our lives. It just goes everywhere. Everything that touches us on the Earth also can be touched by our improvement in exploiting space.
Perfect. Thank you both. I've got a question from Jim Hillhouse that is about Gateway. Jim, I'm going to hold that for that next webinar. I've copied it over into my notes, so we will make sure and cover that next time. And we'll move on to Gene McCulka's question. He says, there was a piece in Politico today saying that NASA astronauts aren't ready for deep space, pointing out the Artemis 2 crew hasn't been assigned yet, training for the lunar missions hasn't started, and it quotes another astronaut about radiation challenges. And if you have comments about that, and Charlie, I'd ask you to go ahead and start, because I've heard you address that topic before.
Sure. I would simply say that not having a crew named per se does not mean there's not a lot of training going on. The entire Artemis system and its program has got astronauts embedded in it. And so they're training, even though they're not the official crew, they're all training in one aspect or another. These missions have a broad spectrum of activities that are required to pull them off, whether it's working in the control center, whether it's working behind the scenes on payload development, new suits development, the guidance, navigation, and control of the Artemis and the Orion, the mission concepts of what happens on what days, the flight planning. It goes on and on and on, and crews are embedded in all of that across the spectrum, which is a training of sorts on its own, and they are in the process building a training program for the specific flight crews to come. So that is in fact the way we've always done these things. And so you know, the other piece that you mentioned about radiation truly is a challenge. And I would kind of put forth the concept that going to Mars, for instance, or back to the moon is not nearly as challenging from a systems technology standpoint as it is from sustaining human life standpoint. And I'll let Doug talk a little bit about that with his more recent experience with space station, the long duration flights that crews have experienced there, and those challenges to maintaining human health and radiation. There are advances in radiation protection. We're going to need that forever when we leave the planet and go outside the Van Allen belts, but those are challenges that can be overcome, just like all the other challenges we've had in space exploration. So I think you'll find some surprising results as we get deeper into the Artemis manifest.
Sounds good. Doug, do you want to add your perspective from your experience here?
Yeah, you bet. Yeah, we didn't have a training program leading into DM2. We had to develop it. So, comparatively speaking, for Artemis, just as Charlie alluded to, astronauts have been doing evals and procedure development and different operations concepts with Orion and Artemis for many, many years. And so it's kind of the same thinking as astronauts. When we get selected for the astronaut office, we go into what would be termed a generic training flow. For at my time and Charlie's time, it was shuttle, and you got to a level of proficiency on shuttle generically, and then you could train mission specifics much more efficiently and quickly. And it's the same these days. And so what I would say is, in fact, I'm fairly certain, don't quote me on this, but I'm fairly certain we've already picked a Canadian to fly on this mission. And I think the other 3 yet unnamed astronauts are US astronauts. But given that, and given that we're probably at least a couple of years away from Artemis 2, give or take, I don't know the specifics of the manifest for Artemis 2, but I think it's a couple of years, maybe a little less. And the mission profile, which is essentially launch, do some work in low Earth orbit or high Earth orbit with maneuvering the vehicle just to make sure that works, and then free trajectory around the moon. From a training standpoint, that is not intensive relative to some of the surface missions to the moon and all the different things you had to do there, and the certainly some of the assembly missions we had with shuttle building the space station. So there's plenty of time for the crew to get trained. And from a radiation perspective, I would agree with Charlie. We've got advances. We track radiation on every astronaut. I know exactly how much radiation roughly I was subjected to in my career, and it's monitored very closely. And I think for a mission of this duration, radiation is certainly always going to be a concern, but there definitely are advancements in protection that'll keep the astronauts safe.
Thank you both for that. And I have to add, in case you're not following the chat, on Gene's question, he says, I really wish the author of this piece was on here. They need it. And so Gene, invite him to the next one.
Yeah.
And that's the whole point of these webinars, to provide background on a variety of topics related to space exploration. So when we're writing about Artemis 1, we've got all the details and background. So I appreciate that. And just have one more follow-up question to that from Alexandra Weitz. And so I'll ask that, and then I believe it'll be time to wrap up. But she asks, to follow up on Gene's question, how much field geology training are the Artemis astronauts getting? Is it enough to have them prepared to do geology on a notional 2025 landing? Who wants to take that one first?
Go ahead, Doug.
Yeah, I'm certain it'll be at least as much as what the Apollo astronauts were given. As I mentioned before, and maybe Charlie was able to do it as well, but we did geology training. We spent a week in New Mexico. Gosh, I can't remember the guy's name, but he was awesome. He was an awesome, just a PhD geologist, and it was, he had actually trained some of the Apollo astronauts, and gosh, I can't remember his name, but anyway, it was just really enjoyable. Back, when I joined, I guess we probably did it in 2001 or 2002, but we still do that generically. And then once again, as I said before, there will be time in, and probably that will be a huge priority for those surface missions for those astronauts to be highly qualified to act as geologists. And then I guess the other part is kind of like Harrison Smith. I think we have a couple at least active astronauts that come from that background. So, you know, that always helps. It's kind of like when you are the crew medical officer on a flight and you've got a real doctor on board the space station. It always makes you feel a little better. So, yeah, there certainly will be more than adequate time allowed for that, to the point where I think those folks will be really, really proficient in geology.
Yeah, as a matter of fact, we made a point of selecting astronauts in the classes over the years that represented the scientific community broadly, whether it was pilots, engineers for the shuttle. The mission specialists also, you know, ran the spectrum from medicine to geology to astrophysics, biology, you name it. And so those are folks who are highly specialized in those career fields, and they have a connection to that community. So like Doug says, no doubt there'll be lots of focus at the appropriate levels of expertise when we need it for the geology stuff.
Okay, sounds good. And one more question did come in. Oh, and two more, but we do really just have time for this one more. So I'm going to go ahead and ask it for Ken Chang. He asks, how do you see how Mars exploration will unfold over the next couple of decades? NASA's nominal timeline is for the first crewed mission in the late 2030s or 40s, but Elon talked about sending 100 starships to Mars every couple of years by then, and as Doug knows, one can't disregard SpaceX's technical prowess. It's almost an alternative universe disconnect between these two. So a couple of questions there, but I think, Doug, if you want to attack that one first.
Yeah, I mean, I think a little bit as to what I talked about before. I firmly believe it's going to be a universal effort to get humans to the moon. You know, I'm not necessarily convinced, not to say that it can't happen, and certainly you never want to discount Elon and SpaceX. But what I mean by that is just the investment, the technology, the effort. It's going to have to be shared between space agencies, nations, public, private, you name it, to mount an effort, a sustainable effort to Mars, and an effort that's going to have success. You know, I've been asked this many times. It's like, would you go to Mars if there was no chance of coming back? And no, I wouldn't. And you know, maybe that's just me, but I think the other part of it is, if you go send people to Mars and they don't make it, I mean, certainly it's a possibility, but you know, you want to give those missions a reasonable chance for success. And so, yeah, I also think that, you know, and I remember Chris Ferguson saying this, you know, we're always 25 years from going to Mars, until we start actually setting down with a purpose of designing the architecture and the plans to go there. And it, you know, so 2030s, 2040s, 2050s is probably pretty reasonable at this point, but it's going to take, you know, literally a world effort to do it.
Yeah, shout out to Ken. Long time no see, Ken. Thanks for your question and joining the call today. I would piggyback on Doug's comments simply by putting a reference point around what I'd call the aspirational versus the operationally practical. You know, you can go all the way back to Von Braun in the early Apollo Saturn V days and his schematics of orbiting space stations that look like that classic spiral circular station with artificial gravity that we're still not able to produce. Aspirational, which gets everybody's mind thinking in a direction of let's go accomplish this, and then the operationally practical, which is, okay, we're actually going to do it. How's the best way to go execute that? And those two meet in the middle. And because of the aspirational, we strive to go further. And so I don't find that to be a clash. I find that to be prodding when you're aspirational to get a team, in this case, a country, motivated to pursue an objective that will bring both, you know, predicted and forecast benefits as well as the surprise unpredicted stuff. And so I think that's the beauty of where we are today, with industry finding greater interest and benefit from being involved, is there is a business aspect that's working and there's productivity that's evolving from it. So I think that the prodding is a necessary and a beneficial thing to have to keep those aspirations out there. I'm not sure I would want to be one of the 100 on a single spacecraft for a couple-month voyage to Mars. I'm not even sure I'd want to be on a cruise ship that has 1,000 people on it for a week. But anyway, a lot of people do that, so it's an aspiration. But thanks for the question, Ken.
Yeah, good question.
Thanks, Charlie, and thanks, Doug, and thank you both for joining us for this webinar today. You both have crazy busy schedules, and so I appreciate you taking time to do this. And Kristen, thank you and the coalition for hosting, and I'll turn it back over to you.
Yeah, thank you all so much for joining us today. Thank you, Kay and Charlie and Doug. I think this was a really great discussion and really informative. And of course, thank you so much to Jamil at the Coalition for all your hard work putting this together. We hope you all will join us. Like I said, tentative date for our next Space 101 webinar is May 6th. We keep an eye out for an email for us on that. Hope you all have a good rest of your day and a good weekend.